Hi good people, Titus here for the final portion of our Pong mini-series, where we recreate the classic arcade game in Unreal Engine. In this episode, we'll create a simple AI so we have a single-player mode for our prototype. Let's not waste any time and just jump right into it. Okay, in the last one we created the title screen, which has a quit and a 2 players options, but the single-player mode does nothing. So let's go ahead and fix that. First thing what we'll do is let's right click on our level 1 and we can simply duplicate it and we can leave it as level 2. We'll double click to open it up and hit save selected. With level 2 open, we can come to the little blueprints icon and choose open level blueprint. There's some modifications to the code here. In the original level we created a sub player and then we called a possess function on it. Since we're only dealing with 1 player, we can select these nodes and hold shift and then click delete. We can also get rid of this little node here. And if you hold shift and then delete, it basically deletes without breaking the connection. So that pretty much completes the level code, so we can compile and save. And then if we go back, we have on this side is our BP underscore player. And on this side is our BP underscore player 2. We no longer need that, so we can hit delete. What we can do is create an enemy blueprint. So we'll just right click on our blueprint actor and then we'll duplicate it. But this time we're going to call it BP underscore enemy. We'll double click this, and this one's going to be very simple. We don't need any of the player code, so we can just highlight and delete. You might be able to repurpose the spin code, but I'm actually going to make a different, slightly adjusted spin code, so either way is fine. With that all deleted, we can also get rid of some of these variables because we won't need those in the enemy version of this blueprint. One thing that is going to be different is we will need an extra component. So we can highlight paddle and hit add. And if you scroll down, we need some type of collision detection. So we can use sphere, capsule, box. In this example, I'm just going to do a simple box collider. I'll leave it as the name box is fine, but we do need to scale it because it is smaller than our actual enemy. So it looks like we need to scale on the X maybe by 2. I think that'll be fine. And then along the Y axis, maybe we can do like 10. And then I'm going to scroll down and uncheck the box hidden in games. This is optional, you don't have to do that. Part of it is going to make debugging a little bit easier. But basically we're going to be using this collision detection for when the Pong ball overlaps it, we can tell the enemy to like spin to smack it back at the player. So we'll compile and save. We also need another variable. The variable we need is a spinning Boolean variable, because we don't want to spin if our enemy is already spinning. So we need a way to be able to basically track that. With that, we are pretty much ready to start doing the code. The code's going to be very simple. I'm just going to do this prototype using the tick event. So we'll just do event tick and then zoom in here. And what I can do is from tick, we can do a get actor of class. And then the actor we can check against is going to be the Pong ball. So we call that BP underscore ball. And then basically off the return value, we need to know the ball's position or its location. So you can say get world location. It'll automatically create a reference there, which works perfect. And then we only need the X value from the return value. So if we go back to the level, we're only interested in moving the paddles up and down. We don't want to move the paddle, left or right, or along the Z-axis to change the elevation. If you notice on our gizmo on the bottom left corner, the up and down is currently the X-axis. So that's currently how we have this positioned. So I'm only interested in the X-axis here. So we can right-click and split this, and that'll give me individual access to each of the components, so I can do something with just the X. But we have the ball's position, but now we need to get the paddle's position. So we drag the paddle in, and then we're gonna do the same thing, get world location, And then we're going to split this. Now for this one, we are going to use the Y and the Z, but we're going to use them individually, so we still need to split the return types there. The method or the function I'm going to use to actually move the paddle is going to be interpolation. Fortunately, Unreal Engine has several interpolation functions. The one I'm going to use is just a simple finterp2. You can use the constant, that would work as well, but I'm just going to use this one right here. The way this works is it basically takes a current float value and it has a target float value, and then you can basically pass in some time scaler, which we're using the tick function, which comes with built-in delta seconds, so I can just pass that in there and use that. And then we can interpolate it over some speed. So basically the higher the value, obviously the faster it's going to be. So what's interesting about that is if you use like a half value, like 0.5 or 0.8, or you know, some lower than 1 value or close to 0, it'll move slower than normal. So it'll be like you can use this basically as a difficulty ramp. So we can actually just simply right click, promote it to a variable, and just call this our difficulty. I think for a default value, just so you can see how it works, I think it's 0. Let's see, if 0 given, yeah, if 0 is given, it's going to jump to the target, so that's going to be like very difficult. But if we use like a value of like, we'll do like 0.5 starting off, just so I can show you what it's doing, and then we can change that. You know, you can basically set up multiple options where a player could adjust the difficulty, or you can hard code it in, whatever you want to do. But the current position that we're going to need is going to be the paddle's X position, right? So we'll pass that in there. And then we want to move towards the ball's X position. So that'll be the target here. And the way we're going to be moving this is we're going to grab the paddle, and then we are going to do a set world location. And then we can split this transform pin, and we can pass this X value in here. And then we need the existing Y and the existing Z position to be passed in as well. Now there's a problem with this code. Because you're using event tick that runs every frame, it's very expensive. The other issue with that is the ball is not always present. The ball spawns in, and then it gets destroyed, and then a new instance of the ball gets spawned. So you cannot just simply roll this into this. You will get an error because in some instances the ball will not exist. So what you can do is you can use a isValid check, and then we can pass in the return value of the ball to be here. So basically this will say, only do this if this thing is instantiated, if it's created, if it exists. If it doesn't exist, do nothing. And then with that simple code, if we can compile and save, nothing's gonna happen because we don't have the enemy placed in. So let's drag them into the scene. We'll reset the transform, and then the Y position, I think, needs to be 2000 or negative 2000. Yeah, 2000. And that puts him completely opposite to the player. Now, if we hit play, the ball spawns. You'll notice that he lethargically moves towards the Pong ball. So not very good. So he's very kind of dumb. Now, if we go back and we select our difficulty, let's actually make this 0, which I think jumps directly to. So you see he's a lot quicker, and he's going to basically move a little bit faster here. And let me see if I can spike the ball. Nope, I missed. Yeah, you see he's moving pretty quick. So you don't have to do that. You can set it to like, maybe you do like 5. Let's see what that looks like. Oh, I messed up. Missed again. So 5, he's kind of dumb too, so that might be like a good average. But he's still moving like to hit the actual Pong ball. But if you use like a much higher value too, like maybe we do 500, then that should be pretty much near instant as well. Of course I missed. There we go. Oh yeah, so you can basically adjust the difficulty ramp just using that, so I'll move them down to maybe a 10, which is more reasonable, I think. Okay, but that's basically the movement code, but we don't have a way to give the enemy a way to basically bounce the ball back like I can do, so let's kind of set that up. So what we can do for that is we can use our trigger box, just click it in the components tree, and you can right click, create a custom event for collision, and you can do on component begin overlap. And from here, it's not going to be too difficult. We can basically just cast to the actual ball object, and then on the other actor we can pass that into the object field so it checks, because there's other things it's going to interact with, the bumpers. So the collision box will hit the bumpers, so you don't want it to spin when it detects the bumpers if he goes too close to the top or the bottom of the screen, for instance. And then we'll want to pull that into a branch check. And then what we want to do is we want to hold control and grab the is spinning. So you only want to spin if the player is not already spinning. So we're going to pull into a not Boolean. And then I'm going to pull into an and Boolean as well. And for now, I'm just going to check this so it's always true. And we'll come back to that in a second. So basically, if the player is not spinning, then what we'll want to do is we will set is spinning to be true. And then we'll want to create a timeline. Call it enemy spin. And we'll want to play from start. And then we can grab our paddle. And we'll do a set relative rotation. And then on the update, we'll pass that here. And then we can split the structure pin because we're only going to be rotating on the Z axis. When the timeline is finished, we will want to hold Alt, drag our is spinning in, and set is spinning to be false. That way it gives the enemy the ability to spin. Now we have to create a value in the timeline, so you just simply double click it, and it brings you to the editor. Spin function was happening pretty quick. For the player, I think we used 3/4 of a second for the length of the timeline. Then you can add a single float track. I'm going to call my float track rotation, but you can call it whatever. Doesn't really matter. And then I'm going to right click, add a key to the frame. I'm going to add 3 keys. First one is 0, 0. The second one is going to be at 1/4 of a second. And I'm going to go 20 degrees up. And then the last and final is at the end of the timeline, or at 3/4 of a second. I'm going to rotate negative 720 degrees. And this is basically my timeline. Now if I go back to the event graph, I have a rotation pin now. I can pass that along the Z axis, or into the Z axis, I should say. And that pretty much almost completes the code here. We can test it out. The enemy should spin every single time. Yeah, so you see that's kind of working, and if he hits it again, so maybe you don't want the enemy to spin every single time. Maybe only want to do it during set conditions. Oh wow, that's a bug. We'll have to figure that out later. The way we can accomplish this is on the and Boolean. You can actually pull off that and do a random bool. So we compile and save. Now the AI basically has a chance to spin. Oh, there you go. actually get a score in or two when he's at a difficulty of 10, so that's not too bad. Oops. Okay. So that's working okay. So that completes basically the spinning and simple AI code there. One last thing we're going to have to do is we need to set up the title screen. So if we go back into the title screen level, you'll notice that we have the options, but if I choose one player, that's still not working. So we open up our title screen widget we've created in the last one. We have these buttons. We got 3 buttons, one for quit, one for 2 players, and one for 1 player. So if I highlight that, and then in the details inspector, you can scroll down, and there's a events section. We can do an on-clicked event. It'll automatically add this to the event graph. You can see in the other one we just did a simple open level by name, so that'll work for this as well. And then we just pass in the name of the level, which I think in this case we called it level 2. And then we compile and save. So now the quit still works, 2 players still works, and then 1 player should pit me against the AI. It looks like that's working pretty good as well. Alright everyone, this completes the Pong mini-series, but I hope you found some informative value that you can take into your own projects. But as always, thanks for watching, consider subscribing to help grow the channel, and I'll see you on the next one.